The next example I want to show you of an oxidation of an aldehyde is this Tollen's test that we looked at virtually on the lab. Okay, a little bit of naming review here. This is benzene, and it has an aldehyde functional group, so we're simply going to call it benzaldehyde. Okay, this right here is a real big representation of something that you know as a Tollen's reagent. Now, you're not going to have to know how to write every single little bit of this, and you're really not even going to have to know exactly how to name it or anything like that. This is a complex ion here, and it's occurring in water. So the reaction is occurring in water. That's why you have the H2O here. Okay, let me draw your attention to what is very important, and that is this silver ion right here. Notice that I said silver ion, and I called it a silver ion because it has it's +1 charge. Okay, so it is an ion in this Tollen's reagent. And then remember, it had a name, that long name, like the diamine blah 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 blah. Okay, that's where that comes from right here. Okay, but we don't have to worry about that. That's not what's really concerning us. What we really want to know is that this goes from a +1 after this reaction to a 0 charge, which makes it an atom, not an ion. Okay, so this is that silver coating that we see that makes that mirror, that silver mirrored type coating. Okay, so this number is reduced. It gets reduced because you go from a +1 to a 0. That's a reduction. Okay, so silver is reduced from silver +1 to your elemental silver, what you see, that silver that you see. Now, when is it a +1? When silver is a +1 charge, it's in solution and you're not going to see it. So when they added the Tollen's reagent in there, they just added some clear solution and you didn't see the little silver ions. That's because they were in a +1 state and they were ions. Well, a reduction reaction happened, and this is a complicated, inorganic concept that we should have covered a little bit better in inorganic chemistry, but because of time's sake, we kind of didn't go through it as we should have. But all you need to know is that this is clear when they add it right here because it's in solution and it has a +1 charge. But then after the reaction happens, that silver is reduced from a +1 charge to a 0 charge, and it falls down to the bottom. It's a precipitate, it's heavy, and it falls down to the bottom of your flask, of your glass container, and it produces that silver coating. Now, when something is reduced, something else has to be oxidized. Okay, so oxidation and reduction, they're commonly given the name redox reactions. Because when one is reduced, another one has to be oxidized, or vice versa. When one is oxidized, another one has to be reduced. So if you'll notice over here, this carbon is oxidized. This benzaldehyde is oxidized to benzoic acid. Remember, all we do is, instead of, the aldehyde, We're going to take that aldehyde off there, and we're going to add oic acid. Okay, so it goes from benzaldehyde to benzoic acid. This is the Tollen's test that you saw on the video. So the big takeaways here. I'm not asking you to memorize this whole reaction. I'm not asking you to memorize what is the formula for a Tollen's agent. Not looking for that. This is what I want you to know. That the Tollen's test is an oxidation reaction. The silver gets reduced from an ion to its elemental form with a 0 charge, and the aldehyde is going to get oxidized from this benzaldehyde to the benzoic acid. Okay, so silver's reduced, benzoic acid oxidized.